One question that people often ask is, since we have three variables, t, x1, and x2, why don't we just use a 3D coordinate system for graphing? So in other words, why don't we take our usual x, y, z 3D coordinate system and do something like t, x1, x2. And honestly, we could do that. For instance, in the example we were just looking at, remember our initial condition I abbreviated initial condition as IC. So the initial condition from the example was x of 0 equals 2, x1 of 0 equals 2, and x2 of 0 was 4. In other words, we have the ordered triple 0 for t, 2 for x1, 4 for x2. And we could certainly plot that on our coordinate system here. Let's put 2 there on x1 and let's put 4 there on x2. So let's see, the point where t is 0 is going to be on the back wall, and that point is right there. So that's the point 0, 2, 4. So nothing wrong with that. Why don't we do it then? It turns out it's just not helpful. So it's okay, but not helpful for visualizing the behavior of the solutions. To get some idea of why this might not be helpful, let's recall that our 3D coordinate system has independent variables, 2 of them, on our horizontal axes. And by horizontal, I mean the axes in the horizontal plane, the xy plane. So those are 2 independent variables. And our 3D coordinate system is meant to help us visualize how the function z behaves, where z is a dependent variable and it depends on the 2 variables in the horizontal plane. That's not what we have, though, when we're dealing with systems of linear differential equations. We only have one independent variable, t. And x1 actually depends on t. So it's not independent. And similarly, x2 depends on t. So a 3D coordinate system just doesn't help us visualize what's going on if you have one independent variable and 2 dependent variables.